Welcome to this tutorial video. This is the second video in the tutorial sheet series under static equilibrium. This is a question I left you guys with last time. Those that didn't have the chance to solve the question, you can pause the video and try the question. Alright, so in this question, we're taught to find the mass M, this mass there, that will be needed to suspend the leg as shown in the picture right there at the corner. Alright, so we're told to say the mass, we're assuming the mass of the leg with a cast is 15 kilograms, and the distance of the center of gravity from the hip joint, all right, that is 35 centimeters, and the cord holding the string is 78 centimeters from the hip joint. So we have these dimensions, these distances. We have 78 centimeters, that is a string holding on to the leg from the hip joint. Okay, then we have another distance there from the hip joint to the center of gravity, and that is 35 centimeters. So this is static equilibrium. A static equilibrium has only two conditions for an object yes, to be in equilibrium. The forces, the summation of forces in the x and in the y should be equal to 0, and the summation of the torque also should be equal to 0. So in this case, I want you to consider the fact that also we have the weight. This leg has a weight, we'll say W, and there's tension in these two cords. Okay, so the tension in these two cords should be the same, and this tension, the force tension in these two cords should be the same in order for the leg to suspend. All right, in order to support the leg to suspend, the tension in the two cords should be the same. So that information, that's enough for us to find the value of M. And for this question, we only use one condition of static equilibrium, and we'll consider the condition for torque. So in this case, we have to choose the sign for our torque. So in this case, we'll consider the downward forces to be negative and the upward forces to be positive. And can get into the solving. So this will be summation of torque. Let me use a black color. Okay, summation of torque should be equal to 0, and we're considering the forces that are down. One of the forces down is the weight force. So the weight force, torque, is given by force times distance, and the weight force, if you look at the weight force, is from the center of gravity. In this case, our hip joint to be the pivot. We'll consider the hip joint as our pivot. So the weight force from the center of gravity to the hip joint, the distance there is 35 centimeters. So converting the 35 centimeters to meters, you should get the W being multiplied by 0.35 meters, and that will be added to the force. I said the force in these two, the force tension in these two strings in the two cords, should be the same. So we'll just solve for one because they will be equal to each other. They'll be equal to each other so that they can help in supporting the leg to suspend, in short. So solve the force T, the force tension, multiplied by the distance. The distance it is from the pivot, which is our hip joint there. There's a distance of 78 centimeters. Converting centimeters to meters, that will be 0.78, and the summation of these torques will be equal to 0. Now the weight is simply given by mg, and the mass that is given is 15 kilograms. I've been given a mass of 15 kilograms, and the weight, which is simply the gravitational acceleration, is simply 9.8, and that will be multiplied by the distance from the pivot, which is 0.35. So this will be 15 times 9.8, that will be multiplied by 9.8, which will be multiplied by the distance 0.35, and we should get, well, in short, we're solving for ft. So this other side will be 0.78 ft, and that should equal 0. So this side of the calculations there, if you do 15 times 9.8 times 0.35, you should get negative 51.45, which will be equal to, which will be added to 0.78 ft, and that is equal to 0. Now manipulating the equation to make ft a subject to the formula, this will simply be ft will be equal to negative, ft will be simply equals to it won't be negative because the negative value would have crossed the equal sign, so it will be 51.45, and that will be divided by 0.78. If you do your calculations, you should find, say, the value of ft, rather the value of the force will be 65.96 newtons. So that will be the value of ft, or the force. So the value of ft, our force, is equals to 65.96 newtons. Alright, now we can proceed and find what the question is asking us to find. So in this case of finding the value of the value for mass. Now, as I said earlier on, you should understand to say the two tensions, the tension in T1, we'll call it T1, and T2 are the same. Alright, and these are the ones that are also giving us the value of W. So let's go back to the diagram. The two tensions, this tension there and this tension there, they're the same, and they were equal to the weight that is down here. The weight that is down here, W, not this weight, but this weight here. So we're equaling these two forces to this weight, and by doing that, we can simply find the value that we want to find, the value of mass. So remember that weight is given by mg, and in this case we already have found the weight, which is 65.96. so we replace W with the value of weight, which is 65.9, and this side we're finding the value of m. We know the gravitational acceleration is simply 9.8. So for us to find the value of m, we will divide both sides of the equation by 9.8. By doing so, the value of m will be simply 6.73 kilograms. So what this simply means is that we need a mass of, we need a mass of 6.73 kilograms to help in suspending the leg as shown in this picture there. So that is the mass we're looking for. So you guys can comment in the chat section how best you thought the question could be solved, or what formula you guys used to solve the question. You can bring up your questions and your contributions in the chat section. This is how the question will be solved. Yes, and in the next video we'll consider this question. You guys can try out the question. It's question 9 in the tutorial sheet on static equilibrium. You can go through the questions and go through the solutions in the next video. Thank you.